Hi everyone. So let's start our class. So now we will see Python classes and objects. So basically there's a concept called classes and objects in Python and in many other languages, but we will see this concept with respect to Python. Okay. So let's get started. So as I'm saying that there are like two words. One is class and another one is object. Okay. So these two words we will be using these two words often in this class. So and we will be going very deep into the classes and objects. So let's start with the basic definition. What is a class? What is an object? Right. By the way, this particular programming paradigm is also called as objected oriented programming. Okay. Oops. Objected oriented programming. Okay. Oops. Okay. So, what is a class? This is our first question. The class is basically in Python or in any language, it is just like a map or just like a blueprint for creating the one object. So you can think of the class as a template. So first we are looking just like a raw definition, and then we will be obviously seeing the example, and then it will be more clear. So basically, class you can think just like a template or like a map. Okay, template, or you can say like a map or some layout or something like this, right? Some layout. For example, a car design is a class. So basically you can, if you are designing that on the paper, okay, if this is paper, okay, just like paper, and if you're designing that car on the paper, then the design itself looks just like a basically, I'm not at very good at the design, but yeah. So basically, this design just looks like a class. Basically, class means it's just a template. Okay, it's not the physical thing, and the actual cars on the roads are actually the object. Or in other words, you can say that there is one architect. If that architect is having some map, house map, okay. So this is, let's suppose, map of some house, right? So this is basically called class, right? This is called class, right? Just like a layout. But if you have the real house, okay, if let's suppose there's a real house, something like this, okay, suppose this is the real house, then this is called as an object. So this is, you can say this is an object. Okay, so we will see the examples, so don't worry. So what is an object? Object is an instance, or you can say some example of a class. Each object has its own value. So you will get to understand this with the example, I think, right? So suppose I'm writing class car. Okay, suppose I'm defining there is some class which is, let's suppose, car. Now these are the two variables in this class. One is called wheels and another one is, let's suppose, black. So here wheels and colors. So another is called color, right? So this wheels and color are basically called variable, class variable, or you can also call class attributes. Okay, the technical term is attributes. So these two are the class attributes, right? So for example, if I just write this class car, and if I define wheel equal to 4, and then the next variable is colors, right? Wheels equal to 4 and color equal to black. So will it compile? What do you think? Yes, right? So basically nothing has happened, but yes, this code is running successfully. Okay, so I'm not printing anything, I'm not doing anything, so that is why nothing has happened, right? So we will see that how to make use of the class, but yes, this is how the class looks like. So here wheels and color are the class attributes. Okay, now what you can do, you can basically write something like this, which looks like a function call, okay, which is basically a class. Car is a class, and then you can put the brackets like this. So basically, the moment you do this, okay, this is called that you are basically making one object. So C1 is an object here, C2 is also an object here, right? So for example, if you do something like this, C1 equal to car. So these are the objects. So C1 is one object, right? And similarly, if you do C2 equal to the same thing, so C2 is also one object. So C1, C2 are the two objects here. Okay. Sorry. Now, if you print, let's suppose C1 dot wheels or C2 dot wheels or C1 dot color, C2 dot color, then 4 or black will get printed. Okay, now you can immediately print. Suppose C1 dot wheels, and suppose I also print C1 dot color. Okay, then 4 and black got printed. Similarly, if I do it for C2, then the same thing will happen for C2 also. 4 and black will get printed. Is this understood to you, everyone? That what is happening here? So basically, this line is very important. This line is basically called as like we are creating an object. Okay. So this line is basically the main line, which is basically creating one object. Okay. And once you create one object, then you can basically use those attributes using this dot operator. Okay. So dot operator is also important. Dot operator is basically there to access the attributes, right? For example, wheels is one attribute, color is another attribute. So to access that attribute, you have to use the dot operator. Okay. Cool. So you can say that 4 and black are the two attributes, and if you want to access those, you can access using the dot operator. And what are the C1, C2? Can anyone tell me quickly? What are the C1, C2? C1 and C2 are the objects, right? Yes. So you can say C1, C1 and C2 are objects. I hope that is fine to everyone. Okay. Now let's move to the next slide. Suppose if I print C1 dot wheels, C2 dot wheels, then 4 will get printed. You can also print this wheels using CAR, which is car itself, okay, which is the class name itself. So you can also print wheels or color or anything using CAR. For example, if I do something like this, okay, instead of C1, C2, if I just use a car variable, which is CAR, car name, then also 4 and black will get printed. Okay. So there are multiple ways in which you can basically access this wheels and this color. How? Using the objects, which is like, let's suppose you have two objects, C1, C2, then using those also you can do it. Using the class name also you can do it. Okay. Great. So 4 got printed in all those cases, right? All these cases, 4 will get printed. So now again, for example, like if you view with respect to the architect, so architect uses a blueprint or some map to build many houses. In Python, the blueprint is basically a class. The houses are actually the objects, right? So which means that the moment you write this, right, there is no physical object got created. But if you have those, those variables, which is like those objects, which is like C1, C2, then the objects will get created. Okay. Now suppose if I just say that class student roll number equal to none and name equal to none, then is the class created? Yes. So class name is student, right? Now suppose if I just create one object here, which is S0, okay, then I can just create with student and then these brackets. Then S0 dot roll number, I can, if I print it, it will be none. But if I just assign this to some variable, let's suppose 1, then you can definitely assign it, right? So 1 is some roll number, and S0 dot name, let's suppose Arab. If I print it, then 1 and Arab will get printed. So here you can say that 1 will get printed, and here Arab will get printed, right? So I can even assign those variable names using those objects. Okay. Don't worry, everything will be very, very clear as we move forward. Little bit you might be understanding that there's a class, okay, and using this class, you can create many objects. For example, one of the object is, or one of the student is S0. S0 roll number is 1 and his name is Arab. Okay. So this is first class. Okay, the dot operator we have already discussed. The dot operator is basically used for using the object. You can access the attribute. For example, if you are writing S0 dot roll number, then this dot is one operator using which you can access the attribute of that object. So basically, every object has attributes, right? These are the attributes. You can also define the function within the class, which we will be doing a little later. I mean, today only, but little later, right? After half an hour, we will also see the functions. So or maybe little lesser than half an hour. So we will see the functions. So the functions are also there in the class, and the way you access the function is using the same dot operator. Okay, so dot operator is there if you have attribute or the functions, right? Okay, so 1 and R will get printed in this case. Now, using the dot operator to access the attributes, form is like this: object dot attribute name, right? So whatever is attribute name, these are called attributes, right? These are called attributes. And more specifically, what do we call them? Can anyone tell me? What do we call them? Class attributes, right? So these are the class attributes. Okay. Okay. So each object has its own copy of attributes. This is something which I will just tell you in the detail. So for example, I have the class student. Okay. Let me just go here. I can just insert one shell. Suppose I have this class which is student, right? Now here I have roll number, which is initially, let's suppose, none, and I also have name, right? Which is also suppose none. Now I create, let's suppose, two objects. Okay. So S0 is one of the object which I'm creating, and similarly, I'm creating one more object which is, let's suppose, S1. Okay. Suppose now we have two objects. Now if I print, so let me just remove these. I think these are not important. So I can remove all of these cells. So if I print now, let's suppose S0, if I print S0 dot roll number, then what will get printed? Can you tell me? Similarly, if I print, let's suppose S1 dot roll number, then what will get printed? So initially both are none, right? Is this fine to everyone? Initially both are none. Now suppose I do one change. I say that okay, now S0 dot roll number is, let's suppose, 1. Okay. Now if I print S0 dot roll number, and at the same time I'm printing S1 dot roll number, what do you think it will be? See, see, this is very interesting concept. Okay, I will just explain you. So here S0 dot roll number is 1, but since I'm not disturbing S1 dot roll number, that is why it is still none. Okay, it is still none. So what is happening here, that uh, that this S0 dot roll number got assigned to 1, but the S1 dot roll number is basically not got changed, right? Similarly, if you do it for, let's suppose, for name also, you can say anything. It need not to be string, but let's suppose this is Arab only. Okay. And then if I just print names, so the same thing is happening with the name, right? Okay. So basically, if you print initially both are none, but if you just change the S2 dot roll number, then it will be 2 and Mira. Okay. So basically, if you again print S1 dot roll number and S1 dot name, they are again a none and none. So you are not changing the S1 case, you are only changing S2 case. Okay. So here they have used S1 and S2, so that's fine. Okay. So I hope that is fine to everyone, that I'm not changing the S1, I'm only changing S2. Right? So changing one object does not affect another object. Okay. So each object lives in the unique location in the memory. So basically there is unique location for each object. Two students may share the same value but remain different objects. So basically you can check that where this S0 is stored. So there is something called ID. Okay. ID will tell you the memory location of this object. So this is something some unique integer. So it will print some unique integer. Okay. And similarly, ID of S1 will also be some unique integer, which is different from the above one, right? As you can clearly see that this integer and this integer are different. You do not need to interpret those integers, that what is this integer, I mean how large, and these things are there. So you just think that okay, this is a unique ID for every object that we have, right? And there is something called as type. So suppose if you want to know the type of this object, that this object is of which type, then you can just write type of s naught, then it will just tell you that it is of type student. Okay. Okay, so we will see these in little detail. So currently what I'm telling you, that every object, so you have created S0, S0 has its own memory. You have created S1, S1 has its own memory. In S0 there are two variables, right? One is roll number, one is roll number, and one is name. Similarly, in S1 also there are two variables. One is roll number, one is roll number, one is name. Okay. So this object will be stored in the memory, and these two objects are basically stored in the different memory location. Okay. So S0 roll number is different from S1 roll number. Remember. Okay. So they have their own identity in the memory. Now, suppose I have something like this. Let's suppose car wheels equal to 4. It is black. So C1, C2, there are two objects that I've created. C1 dot color, I'm saying red. Then what do you think that C1 dot color will be printed and C2 dot color will be printed? If I print now, then what will happen? Tell me immediately. Yes, so it will be red only, but here it will be black, right? So you can do it. It's very easy. Red and black will get printed. Okay. Okay. So now suppose there is another class name is dog. Suppose this is having one variable which is Tommy, and name is by default Tommy basically. Now if I just do d1 equal to dog, so one object got created, and if I just print the name of this object, then I mean the attribute which is name, if I print using d1 dot name, then what will happen? So basically you can see Tommy will get printed here, right? Right. Now, interestingly, you can define new attribute on the fly, which means suppose here there is no attribute called age, but you can do it on the fly. Once the object is created, Python is very user friendly, right? So once the object is created, after that also, suppose you want to define some attribute, you can just do it on the fly. Okay, just like a variable. See, for the variable age, you just write age equal to 5, right? Then age is a variable, right? Now if you want to define it as an class variable or as an attribute, okay, then you can just do d1 dot age, right? Then it will be 5. So basically now if you print d1 dot age, it is 5. Just I'm telling you that you can even define the attribute on the fly. Although these things are not much important for us, but yes, you can do it. Okay. I mean, every language has many hidden things. Okay, and not everything is important to us. But still, I thought it is good to tell you that you can even define the attributes on the fly. Okay. Now, let's introduce. There is some weird looking function which is called init. Okay. So what it does, let's just see. So suppose you have a class dog. Now what you can do, you can write something like this. Inside the dog, so you can directly write some variable which I have already done, like Tommy. Okay. Now instead of this, what you can do, you can basically have you can say object wise variable, which means every object will be having a different name. And how does it happen? Let me just tell you. See, suppose let's go here and let's start writing the code. Suppose there is one class, right? Now, if I write like this, so by default, let's suppose I'm saying the name is Tommy, right? Okay. Now, suppose I'm saying d1 dot name, sorry, d1 equal to, first let me just create the object dog, and I'm also saying d2 equal to dog. Now, suppose I say d1 dot name equal to, can you suggest me some good name for a dog? Okay. Suppose I say Barno. And d2 dot name, let's suppose I say uh, okay, Rocky. Okay. Suppose these are the two names. And if I print those names, then you can definitely do it. How? Using d1 dot d2. So this is d1, this is d2. Now if I print it, Barno and Rocky got printed. Okay. Now, one thing you see here is that there is a little bit of inconvenience, I can say, which is that once I'm creating the object and then I'm basically naming them, right? I mean, or after creating the object, you can say that I'm modifying the attribute values. Okay, but sometimes it happens. Like for example, let's suppose you have the class dog. Oh, sorry, class. Let's suppose you have a student. Sometimes it happens, many times, not just sometimes, it will happen that the student is having, let's suppose, two attributes. One is the roll number. Okay, suppose the roll number, you are saying it is none, and name, it is, let's suppose, it is also none. Don't you think that these are the two attributes which anyway you have to define the moment you create the object? For example, you create the object s1, okay, which is first student, let's suppose student. Don't you think that immediately after you create the object, you have to do something like this? I mean, ideally, right? If you are working with a practical code or practical project or some database, then don't you think you have to immediately do it? Like, for example, S1 ka roll number is suppose 1 and S1 dot name is something like this. Some, let's suppose, Arab. So immediately after creating the object, sometimes we have to name the attributes, right? Sometimes we have to change the values of the attribute, because those has to be done, like those kind of unique numbers or those kind of identity of that object, or that's the purpose of creating the object. So similarly here in this case, the name you will by default modify, right? So it is like little bit of cubism in the sense that once you create the object, then you modify the attribute value. These are the two-step process. But I don't want this two-step process. Suppose I want to do all of this. Okay, so I want to do all of this, let's suppose, using just one line. Then what is the way to do it? And no, it is not about just shortening the line, or it is not only about having the lesson line of code. It is about the convenience. It is about the practicality, because later on you might do some mistakes, like, okay, and you might not remember whether you modified the name or not, or something like this. So basically there is another way to do it. And what is that way? Using the init function. But before we go to the init function, have you got the problem that I'm trying to address? The problem is that there are like multiple attributes that you will be immediately after creating the object, you will be anyway modifying. So why not, the answer is why not we assign this one in Arab at the time of creating the object. So I hope you are getting my point. All I'm trying to say is that many times we need to assign values of attributes immediately after creating the object, right? So my answer is like, why not we do it at the time of object creation, right? Okay. So I hope that is fine to everyone, that what we want to do and how we do it using the init function. So I will just come to that. Let me just post it here. The problem is that we will anyway be defining the new attribute values, okay, immediately after creating the object. But init says that what you can do, let me just, write this here itself. So def underscore underscore init. Okay. So when you put two underscore, it seems like just like a line, but these are the actually two underscores, right? And then underscore underscore. And then you write something called a self. I will just come to that. What does this self mean? And then you write your variable names, roll number and name. Self dot roll number equal to roll number. I will just explain. Give me a moment. Self dot name equal to name. So instead of writing like this, I will be basically writing like this. See, can you see the difference between these two codes? So here what is happening? Initially by default, there is some roll number and name, right? Now you create the object, then you modify these two values. But here what is happening? That you are basically writing these two values at the time of creating the object itself. So I will just tell you the syntax, but before that, first let me just print some values. S1 dot, let's suppose roll number. If I print the S1 dot roll number and if I print, let's suppose S1 dot name, then let's just see what's get printed. So 1 and Arab got printed. Is this fine to everyone? Let me know. Is this fine? So 1 and Arab got printed, right? Now, in this case also, in the below case also, suppose I do print these two, then 1 and Arab will got printed. But which one you think is more convenient? The first case or second case? With the init function, it is more convenient, isn't it? Yes. So why that is the case? Because there is no chance of mistake also. You know that okay, this S1 is related to 1 and Arab only, right? And it is more convenient also. So that is why we have this init function. Okay. So I hope you understood that what this init is doing. Now let me also explain you first the syntax of this init. So the syntax look like this: self, comma roll number, comma name. So self, you can just ignore for 5 minutes. You will get to understand. Self is basically you can say some variable. I mean, this is not a keyword. You can have anything here X Y Z also. Okay, it will work fine. This is so I again executed it. Okay, if you even if you do XYZ, it is basically working fine. But generally the convention is that we write the self here. Okay, you will get to understand why this is the convention. Otherwise, the Python doesn't say that you can write anything here. Okay, self is basically is there to say that okay, this particular object that you're creating is basically referring to S1 only. Okay, but till now, since we're creating only, but till at this point in time, we don't have the reference to S1 or we don't have S1 created. So that's why we write the placeholder or the dummy variable, which is you can say self. Okay, so it is for the internal use of the Python. Okay, comma, then you can write basically self we will be anyway writing. Then you can write any number of variables. Okay, so for example, roll number, name, or any number of variables, and then the self dot roll number is equal to this roll number, which variable name you are writing here. Now, again, this roll number is also not, need to be roll number itself. I mean, it can be any variable name. For example, if I do like this, then also it is working fine. It is 1 and arrow. So basically, these are just variables. I mean, these are, you can say, the placeholder which will be taking the value 1. This roll first variable will be taking the value 1. The second variable will be taking the value arrow. Now, is this also a variable, or technically, do you know what is the name of this particular thing? We call it attribute. Why? Because anything which I'm accessing with the dot, we call it attribute, right? Anything which I'm accessing with the dot. Okay. Since I'm accessing this roll number with the dot, that is why this roll number is an attribute and this roll is just a variable. Is this fine? I mean, this role is just anything. Okay, X, Y, Z, P, Q, R. These are just anything, right? And it will work. See, This roll number is one of the way that we are defining our attribute. You can I also told you that you can even define the attribute on the fly, right, using the dot operator. So similarly, using the dot operator, this is the first time I'm defining that, okay, I have the attribute roll number. Okay, so this is the first time I'm defining that, okay, I have the attribute roll number. This is the first time I'm defining that, okay, I have the attribute name. Okay, and what is the value? I'm also initializing the value using this one and rm. Okay, you can write it anything here, doesn't matter. But the convention is that we generally write the same things here. I mean, the variable name also we write the same thing here. Okay, so this is the convention and it will also work. So basically this roll number and name are the local variables of the function, but this roll number and name are the attributes of the object. Okay, so anyway, we will be having all of these things in the slides also, and everything is already there in the slide, and we will be walking through the slides. We will be understanding this in more deeper way. But currently, is this okay to everyone that what I'm trying to say? See, don't worry about the self. Self, you can just mug up, okay? For now. For now, you can just, by hearted that, okay, there is some syntax called self and comma, and then self dot something we write like this, okay? Basically, self is there to say that, okay, currently we have not created the object which is S1. Okay, that is why I cannot write some object reference directly. So that is why we just say self. So self means that the object reference will be here, will be replaced. Python will automatically be doing it. Okay. Okay. So have you understood the syntax of the init, that what the init is doing? Now let's just see. Okay, let's just see more that what it is doing. So def init self comma name. So basically what I'm doing, I'm defining my attribute name and its value is actually the same. Okay, which is name. Okay. So here, I can do plus two. And then what will the answer? It will be 3, right? I mean, 1 plus 2. Can I do plus 2 here? Is this possible? No, right? I mean, there will be immediately an error, right? I mean, this is just an attribute cannot have plus 2 or something like this. So basically, you just see here, this is a local variable, okay? And I can do anything with this local variable, whatever I want to. This is attribute name. This is the difference between these two. Okay. Now, D1 is one object, D2 is another object. So, Tommy and Sheru, let's suppose, sorry for the names. Okay, you might be having your favorite name, but yeah. So, these are the names that I've used. So, Tommy and Sheru will get printed, right? Okay. Now, see, this init is a special function or special method that runs automatically when you create the object. So it is automatically running. You don't need to call it. Actually, Python internally call it. The moment you do this, okay, car or dog or whatever the class name. So I think car or dog, okay, whatever the class name. The moment you do it, automatically this init will be called. Okay, automatically it get called. Now it is used to set the instance attribute unique per object. So basically these are the two things which we'll be seeing little later. I mean the technical names we will seeing little later, but yes, if you're defining something within the function, okay, even it is init function or any other function, some attribute within the function, then it is called instance attribute. Okay, so this is instance attribute. This name is basically per instance, per object attribute. But if you are doing it, okay, without the init function, if you are doing it outside, let's suppose here, then this is called class attribute. This is a class attribute, and I mean these are just technical name. If you are doing it without the init function, then these are called class attribute. But if you are doing it using the init function, then it is called object attribute or instance attribute. Okay, don't worry, everything will be very nicely clear as you move along. So let's just see what is the output of this. So class car, def init, brand year, self dot brand equal to brand, self dot year equal to year, right? So Tesla 2024, then what do you think it will be printing? So this brand is basically Tesla and this is 2024. Okay. So you can say that when I'm printing this C dot brand, then automatically Tesla in 2024 will get printed. Okay, I don't have the answer, but yeah, this is easy question and Tesla in 2024 will get printed. What about this? Now here, by default, I'm saying the name is guest. Okay, if I'm not giving at the time of the object creation, then it is okay. Okay, by default, I'm saying the name is guest. So it will say guest, and then if you're passing the name, then it will say Neha. So I think guest Neha will get printed, right? So guest Neha, which is 2. Is this fine to everyone, or should I explain this? Okay. So see, if you have seen the lectures, then you know what does this syntax mean. So just complete all the lectures, all the Python lectures before you come to this lecture. Okay, then you will get to know that what does the syntax mean. These are the default variables. Okay. So what is self? So self is basically in Python, every method inside a class automatically takes the object itself as the first argument. So basically, not just in it, we will be seeing the other methods or other functions also. There also we have the syntax called self. Okay, we need to write the self comma. For example, let's suppose I do not write the self. Okay, I do not write the self. Suppose here I'm okay. Suppose here I'm writing the self. Let's not worry about it. Let me define another, you know, function. Suppose modify. And suppose here the actual syntax is this. Okay. The actual syntax is this. Suppose instead of this, so this is the actual syntax and it will get compiled. So if I just print, sorry, not print, if I just call s1 dot modify, so basically this is first time I'm defining a function, so you might be a little bit confused, but don't worry, it will be clear. So suppose instead of Arab I'm giving some other name, let's have Bunny. Okay, now if I print s1 dot name, then what will happen? Bunny will get printed, right? Why? Because self dot name, which means this object attribute, I modified to the whatever I'm passing. Okay, this is just a local variable, but the convention is that you write like this. Okay, this is the popular convention. Is this okay to everyone? Now suppose instead of this self, I mean I do not even write this self. Then what will happen? See, there's an error. Now let's just read out this error. What is this error saying? Student.modify takes one positional argument, but two were given. So basically, it by default, actually, it see the way I'm defining. Can you tell me how many arguments I'm defining? How many arguments it is taking? One, right? Currently, it is taking one. But Python by default, okay, by default pass the object reference. So basically, the way Python internally call this function is, let me just tell you. See, student dot modify s1 comma bunny. See, actually, I'm calling like this, right? See, I'm calling s1 dot modify, but internally Python calls like this. Obviously, you don't need to know these internal things, but I'm just telling you to make sure that why would we write self. So Python internally calls like this. I mean, Python has to tell that okay, I'm basically talking about the s1, right? So it automatically writes the s1 here. Okay, so see the error is like student dot modify, because Python is calling internally this student. I'm calling s1 dot modify, but Python is calling student dot modify, and Python by default puts one of the first argument as the object, right? Which object you are using. So currently I'm using s1. So Python is saying that okay, I'm calling like this, so which means that I'm having the two references or the two arguments here, s1 and 1. But the moment I went to this modify function, I found okay, it is just taking one, but you're calling with two. Are you getting my point? So basically, ultimately, just remember like this that you always write self. Okay, always write self. That's the only point I want to say. Okay, why? Because Python will call something like this, and the first is object reference that is taken by the self. Okay, and then the second is whatever, or the third, and so on. These are the variables whatever you want to use, right? But the first has to be self, because Python internally uses like this. Okay, so let's just come to the slides. So basically self is something which is Python calls a method inside a class automatically, takes the object itself as the first argument. So whenever Python call, okay, then object is the first argument. So by convention, we call it self, but it can be actually anything. It refers to the specific object. So for example, self is a convention. You could name it differently, but don't. Okay, you should not name it differently. For example, you can have XYZ also here. You can have anything. Okay, XYZ name equal to name. It is also fine. Use XYZ instead of self. Okay, so Sheru is, let's suppose, another dog name. So print d2 dot name Sheru. Self is not a keyword. Remember, you can rename it to XYZ, OBJ, this, okay, this or that or whatever, right? Anything. This meaning, the meaning does not change. It still points to the same object. So basically, this is just a placeholder. Self is a convention. Remember, not a keyword. Technically, you can use another name, but don't. Okay, use self. Okay, technically, you can do anything, but don't do it. Use self. Now you notice here that this is also name, this is also name. So why two names, right? Why two names? So basically, the left side name is an attribute. Right side name is referring to the parameter passed into the init function. So they are different. One belongs to the object. One is just a local variable. This is the local variable, right? And whatever you are using with the dot operator, it is actually the attribute. So for example, these could be different also. This is name. This is given name. These could be different also. Okay. Now, suppose this is dog name, everything is here. Like this code is fine, but the moment you're calling, okay, or you're printing this attribute which using the d4 object, then the moment you're doing, you have to be using the same attribute, which is basically dog name. You cannot use any other name, which is name. So this name will be error because dog name should be there. So this will be error, but this is fine. Okay. Now, suppose there is an init function. Here, I have val as an attribute, but I'm not passing it. Okay, I'm not passing the value of attribute, which is also fine. So by default, it will initialize to 0. So suppose if I create the object, I'm not passing anything, right? I'm not passing anything. And then automatically, if I just print it, it will be printing 0. It will be printing 0. Is this fine to everyone? So it is not necessary to pass anything. So for example, so okay, this is fine. Counter, okay, let's just write the code from starting. Counter, and then end it. Self dot val equal to 0. What was it? C equal to counter, and if I print c dot val, so c dot val will get printed as 0. Okay, simple. Okay, but self is important. You have to write the self. So let's just see that how we define other functions, okay, inside a class. For example, I want to define some function called bark. Okay, so I can just do like this, and then self is important for every function. If there is no other variable, it is fine. It is just printing woof woof. Okay, so d1 equal to dog. So the object got created, and d1 dot bark will print woof woof. Key idea, when you call a d1.bark, Python internally calls basically, actually it is not needed, but yeah, Python basically calls like this dog.bark and then the object reference, which is d1. Okay, so Python will call like this, and then which means that dog.bark will got called, and this d1 will be passed as self. Okay, so Python since always uses some one parameter here, so that is why you always have to write something here, and by default it is self. Not by default, I mean, yeah, by convention it is self. Okay. So for example, this is another function that we are using. The function name is calculator. Add will do add, and let's suppose multiply is doing multiply. And then if you call it with c dot add 2 comma 3, 5 will get printed. If you are calling with multiply with 4 comma 6, then 24 will get printed. Okay, because we are returning also. Let's solve this question. So what do you think it will be printing? Put self comma b. So don't remember the self again and again. You can immediately ignore it. Okay. So basically, it is saying that you are passing one value, right? So there is no init function, which is fine. I mean, you are not having any variable which you want to initialize. So that's fine. So basically, you are now directly doing put, right? So put 10, which means v value is 10 here for b1, and b2 v is 20, right? So 10 comma 20 will get printed. Okay, very easy. Okay, 10 comma 20 will get printed. So there is no, it is not necessary that you write your init function. Init function is not necessary if you don't have any variable that should be initialized. If there is no variable to be initializing, then you can just skip the init function. Okay, init function is never necessary. Okay, suppose I'm initializing with the 0, and then I'm calling the increment function, okay, which is doing plus equal to 1. Then if I just call this something like this, then what will get printed? 1, right? Because initially it is 0. So at this line, val is 0, right? And then after this, the val will become plus equal to 1. Okay. Let's see this question. What is the output if we execute this? See, there is some greeting, some variable, which is basically sir. Okay, by default it is sir. I mean, at the time of initializing, it is sir. So here it is sir. And now after this work, I'm not passing anything to the work also, which is fine. Self dot greeting, which is sir, then comma I work, right? So sir I work. So B is the answer here. It is also easy question. Okay. What about this? So here it is sir, and then self dot greeting equal to self dot greeting dot upper. So basically in the strings, there is a function called upper, which will do if I mean for ABC dot upper, it will do the ABC. Okay. So now this work is basically modifying the previous greeting to the upper. So basically previous greeting is sir, so it is capital S, capital I, capital R, and then it is returning previous greeting plus I work. So what is the answer here? See, for this W dot work, it is a function, right? W dot work is a function. So what will get printed? Sir, it is returning sir, SIR, capital SIR, I work. So because of this, sir, I work will get printed. And because of this W dot greeting, what is the value of greeting now? Can you tell me? See, you're modifying here, right? You're modifying using this function. Okay. So since you're modifying, it will be again sir. So because of this, sir will get printed. So sir, I work. Okay, don't worry about this. And then, and then will not be the part of output. So what is the answer? B, right? So let me just remove this and then. Okay. This is also easy question, right? Now let's move to the next slide. So B is the answer. So what they are saying, this seems to be little interesting question. So here you have item, and then you have inside. These are the two variable. Inside is by default none. Okay, which is fine. Now item and inside you are anyway initializing. Okay, so the moment you create one object which is box, what is the item now? B dot item. What will that? What is B dot item? It is pen or pencil? It is pen only. See what is happening. This box. See, the moment you call something like this, b equal to box of something. So this is b. Okay. So this is one object which is b. Here you have two variables. What is that variable? One is the item. Let's suppose this is item. Another variable is inside. This is inside. Item you're initializing with pen. Okay. Item you're initializing with pen. Is this visible to everyone? And this inside you're initializing with the with some object. So basically it is a reference, or you can say some pointer. Okay, we don't use the word pointer here, but this is fine. So basically this is a reference to another object which is actually box. Okay, so it is not given, the name is not given here, which is fine. Inside this also there are two variables. One is item, one is inside. Now we are only passing one of the value, right, which is pencil. The another value will be by default none. So basically this value is none here, and this is pencil. So this is the complete memory diagram that you will be making like this. So b dot inside is basically, sorry, b dot item is just pen. Okay. So what is the answer here? Pen. Okay. Now let's just move to the similar kind of question, but the next one. So by the way, for every object you have attributes and you have functions which we call methods, right? Every object has attributes or the functions. Okay, just a second. Yeah. So this is the next question. Now, here in this question, instead of asking b dot item, which was pen earlier, they are asking b dot inside dot item. What does this mean? B dot inside, which means they are talking about this. Dot item means they are talking about this pencil. Okay. So B is the correct answer here. Have you understood? Let me know. Okay. Now let's see this question. I hope that is fine. See, B dot item is pen. B dot inside dot item is pencil. Can you tell me what is B dot inside dot inside? It is none, right? It is none. Why? Because this is none. Okay. Now let's see this. Suppose you are calling this inc two times. Okay. Value is initialized to be 0. Value is one attribute that you are just defining. Okay. This is one attribute. And now you are doing plus equal to 1. But you are doing it two times. So it will be 0, 1, 2 error. What do you think it will be? 2, right? Why? Because you are incrementing two times. So initially at this point in time, value is 0. The moment you do this, value is 1. The moment you do this, value is 2. Okay. So let's just go it here. Self dot val plus equal to 1. And now if you call this inc 1 time and then 2 time, sorry. So it will be printing 2. Is this fine to everyone? Okay. Now, suppose I do this. So basically earlier it was self dot val equal to self dot val plus 1, right? I mean, we are just incrementing by 1. Suppose, so it will be printing 2 only, right? I just executed. So see, it is printing 2 only. Suppose instead of self dot val, okay. Now can you tell me what will happen? Okay, it will be printing 10, it will be printing 5, it will be printing 0, or there will be error. So let's just see. It is printing 0. Can you tell me why? See, this val is what? That's the only point, right? This val is just a local variable. Okay. This is a local variable of this function. Is this the object attribute? See, if you want to modify or if you want to change the value of object attribute, you have to write self dot. Otherwise, it will be treated just like an new variable. Okay, this is just a new local variable. So if you're doing val equal to 5, then it will not impact the original self dot val. Okay. So see, the original could be anything. Original let's suppose 2. Okay, then answer is 2 because increment is not doing anything. It is basically creating a local variable which is 5 and it doesn't relate to the original this object attribute, which is if you want to modify or if you want to change this original attribute, you have to write self dot. That's important. Okay. So now I hope you are able to identify what is attribute or what is a function local variable, right? So whenever if you have to basically modify the attribute, there's a key thumb rule. You have to use dot operator. There is no other way. Okay. You have to use that attribute using the dot operator. Otherwise, it is just a local variable. Okay. So what will happen if I do val equal to val plus 1? Can you tell me what will happen? Okay. Just think about it. See, this is a local variable, right? Have you defined this local variable earlier anywhere? No, right? So don't you think it will be error? So how can you use this, right? So basically it is error. Cannot access the local variable where it is associated. It is not associated with any value basically, right? It will be error. Why? Because you have not defined this well anywhere. Okay. Just it is just a local variable. If you're not attaching it with the self, is this understood? What will happen if you do something like this? Will this be the error? Tell me. Just a second. Will this be the error? Self dot val plus one. So what will get printed? Can you tell me the output here? What will the final value? Final value will be 2, 3, error, or what will happen? See, final value will be again 2 only. Why you are modifying the original self dot val? You are modifying val, that's fine. But self dot val is just being used. It is not getting modified, right? So basically it is just 2. You're getting my point? Self dot val is not getting modified until and unless you write it on the left hand side. Then only you're modifying, right? Now you're modifying, and then since you're modifying 2 times, that is why it is 4. Okay. So basically, let me just go like this. So here, let me just write this as a screenshot. Here it is 2. Why that is the case? Because you're not modifying the self dot val, right? And if you're wondering, just a second, if you're wondering, the self dot val equal to sorry, the val equal to val plus 1. Why that is an error? Because this val is not defined anywhere. Okay, because this val is not associated with any value and you cannot use this directly. So this is error. So this val is not associated with any value. So that is why this is an error. Okay. So now you understood the meaning of self. What is happening with the self? Self is there to access the object attribute. So you must be writing dot self dot if you want to basically access the object of the object attribute. Understood? Okay. Tell me now the last one. Tell me what will happen now. Can you tell me? Now you tell me what will happen. So let me basically. Now you tell me what will happen. The initial value is 2. Now you are doing 2 plus 1. 2 times. What will be printed? Just think about it. So it will be again printing the error. Basically, the error will be there. Why? Because this val is a local variable of this function. This val, here in this val, there is no value that you have, right? In this val, there is no value you have. So basically, it will say again, it will say what is this val because it doesn't know, right? So see here, it will be the error, the same error, the access local variable val where it is not associated with any value. Getting my point? The same error will come. Okay. Why that is the case? Because this val is just a local variable of init function, right? This val cannot reflect here. Understood? So that's the concept of local variable. Is this okay to everyone? That why the error is here? Because both val are different. Both are the local variables. So that is the reason that it will print the same error. And in both the cases, the val is not having any value. Okay. Is this understood that what is the meaning of self? So this val and this val are different. These two val are local variables to the functions itself. One val is not related to other val. Okay, great. So now let's just move to the next question. Suppose I have this question. Can you answer me? What is the answer? So you're having 5 and then 8 plus 5 will be 13, right? So I think A is the answer. So I think answer is not written, but yes. So A is the answer. Why? Because self dot x plus y is 13. Okay, now let's just solve this question. So now they are saying that you are having something like this. Item inside you are just initializing like this. The default value of this is none. Now pen and pencil. So basically again the same case. Item is pen, and then it is basically referring to another object whose item is, so this is B, whose item is pencil. Right? And this is none. I mean, after this line, this diagram will be there. Now they're saying B dot inside. B dot inside means this. Okay. Now they're saying that let's just change it. Okay. Earlier it was basically having the reference of this box, but now they're saying let's just change this reference and let's just change it to refer to some other box which is having eraser. Okay. And then again, this is none. So what is B dot inside dot item? It is eraser, right? So B is the correct answer here. Understood? B dot inside dot item is now eraser. Earlier it was pencil, but now it is eraser. Okay, because you are basically completely forgetting about this box. Now, how to access this box? Can you tell me? Suppose I want to print pencil after this line. After this line, suppose I want to print pencil. Is there a way to access this box? See, earlier it was using this inside, a b dot inside. Okay, b dot inside was this box, but now you're modifying the entire value of b dot inside. So there is no way to access this box now. Okay, so it will be basically the Python garbage collector will be collecting it. Basically, there will no this box is non-accessible. You can say. Okay, you cannot access this box after this line. The moment you modify b dot inside to be anything, you cannot access this box. Okay, because the only place using which I can access this box is this. Now, the moment I lose this connection, I cannot access this box anymore. Okay. Suppose if I want to use this box later on also, then first before modifying this b dot inside, I have to be first writing. Let's suppose c equal to b dot inside. I mean, I have to be first basically storing this value into the C. Now, using C, I can access. For example, C dot item is pencil. Okay. So before I modify B dot inside, before I change its value, I can store that in some other variable. Then I can access. Otherwise, I will not be able to access this box. Okay. Now tell me this. Okay, they have actually done it. Now they have done it. B C equal to B dot inside. Now using C, C dot item is marker. They're changing basically. The things are almost same. That there are two boxes. Okay. So one is this. Another one is same as this. So okay. So initially you can say this is pen. Now let me first make one more. Initially this is pen and it was having reference of this. Now initially this is pencil. Now C is referring this because B dot inside is C. Now C has started referring this. Now C dot item, they have changed from pencil to marker. Have they changed this reference? No, B dot inside has not got changed, right? Now they're using the B dot inside. B dot inside dot marker is what? Dot item is what? Marker, right? Marker. So B should be the answer. Okay. Have you understood what I'm trying to say? That B dot inside is basically this. Dot item is marker. Okay. Because this value has been changed to marker. Has this value got changed? Has this got changed to and started having some other reference? No, this has not got changed, right? Only this has got changed. So this is still having the reference of this, but now inside this you have changed something, which is fine. So you are making it marker. Okay. Yes. Now pencil you cannot get. Okay, if someone wants to print pencil anyhow, pencil can never be the answer because it has already gotten replaced. Now there is no way to access this pencil. Okay, pencil we can never ever get. Okay, there is no way to print pencil after this line. After C dot item equal to marker, there is no way to print pencil. Yes, the moment you write C equal to B dot inside, it means that whatever B dot inside was, what was B dot inside? So basically B dot inside you can say was whole thing, this, okay, this box. Now C will be basically acting as this box now. Okay, C will be this box. So yes, they are basically having the same reference. Okay. They are sharing the same reference. So B and C and B dot inside are the same. Okay. Now suppose I have something like this. Okay, let's just try to understand this, what they are saying. So basically, probably you will be having three boxes here. Now this is A, item is A. Inside is basically referring to some other box. Whose item is B? Which inside is referring to some other box? Whose item is C, right? And which inside is actually none. Why? Because by default it is none. Is this is this diagram clear to everyone that after this line this diagram will be created? Is this clear to everyone? Right? See, I'm saying A. A means its item is A, and then inside is this whole thing. So this is just one box. Okay, these are not multiple boxes. I mean, this is just one box. So inside this one box, you will get to realize that, okay, its item is B, and then it is having the reference of another box. Okay. So X, now they are asking X dot inside dot item. X dot inside is this, or you can say this, or you can say this box. Both are same. Okay. Dot inside means this, or you can say this box. Both are same. Okay. Dot item is actually C. Right. So C will get printed. Now suppose after this line, so let me do one thing. Let me just, take this to the next page. Okay. Suppose after this line, I write something like this here. Okay. At this point in time, I write something like this here. The line is X inside dot inside dot inside equal to X. Okay. Suppose I do something like this, and then I ask the same question. It is little complicated, may not be that much worth it, but then I ask the same question. The print is same, everything is same. Just I'm writing X dot inside equal to X. So what does this mean? X dot inside means this, or you can say this box, right? Dot inside means this, or you can say this box. Dot inside means this, right? Now here instead of none, so basically instead of none, I'm changing this value to X. X means X is basically this box, right? So X means instead of none, I'm changing this value to pointing to this itself. Okay. So instead of none, I'm saying, okay, let me just point to this itself. Okay. And X is this box. X is this box only. So after this line, I'm actually modifying like this. Now someone asked me, what is X dot inside? What is the X dot inside? This, right? X is still same, right? I'm not changing X. X is still same. X dot inside is this, which means this box. Dot inside means this box. Dot item is C, right? Still the answer is C. See, I'm not changing X, so it will not be getting changed. Okay, it is not getting changed because I'm not changing X. Is this fine to everyone? I'm just changing this reference. I hope that is fine. Okay. Let me know if that is understood. Okay. Now, suppose it will be too much, but suppose I print something like this. Okay. Just a second. Suppose I print. So I write this line here. Okay. And then suppose I print something like X dot inside, dot inside, dot inside. Let's suppose I do one more time dot inside. and then item. Okay. So what is the answer? If I do one more time, dot inside, dot item. So see here, x dot inside is this box, dot inside is this box, three times, right? And dot inside is actually this box. And now I'm printing the item. So which means it will be printing A. Okay. Is this understood, everyone? If I do this line and after this line, if I just do three times inside, dot inside first time, second time, and the third time inside is this itself, right? So A will get printed. Okay. Now tell me what is the answer here. Book you're initializing. Yes. It will be attribute error. Why? Because it is basically having two boxes. One is having book. I mean, the item is book, but inside is anyway none. You have not passed anything here, right? Now you are saying a dot inside, which is actually none. None dot item doesn't make any sense. So it will be attribute error. Okay. So C is the answer here. It will be the attribute error. Reason a dot inside is none, and so none dot item is actually invalid. Okay. Have you understood? So basically, this is none, and none dot item doesn't make any sense. So that's why C is the answer. Okay. Tell me this. So this seems to be interesting, right? So here is a box. Let me just copy the box directly. Okay. So here is a box, and the first value is stone. Okay. Then they are saying that s dot inside the second value is adds itself. So what does this mean? This is stone. This now they're modifying, and they're saying this is adds itself. So it's the self loop kind of thing, right? Now s dot inside is actually now s and s dot inside are actually same. So s dot inside is actually this only, right? Dot item is again stone. So A is the answer here. Okay. So A is answer. No traversal loop occurs. So only access one attributes. So anyway, so A is the answer. Okay. Now let's just quickly see this. So now tag toy and then inside is bag. Okay. First to tell me the answer. What is the answer? Just think about it and tell me the answer. So first attribute is toy, which is the item. Now inside they are saying it is bag. Okay. Now they're saying T dot inside, which is bag, which is a string, right? Dot item doesn't make actually any sense. So that's why it is attribute error. Okay. So because dot item will not make any sense. Inside is a string, not a box. A string don't have a dot item. Okay. It's for the strings, you should not be having dot item. Okay. So let's solve this question. This question I've taken from Berkeley. So what they're saying, Louis Reasoner wants to define a person class. So there's some person class which is name equal to none. So there is some class instance variable which is none. Now person dot name equal to name, and then they're having another function greet. Okay, greet is saying hello, my name is self dot name. So basically, person dot name means this name. Okay, so don't get confused. Person dot name means this name. This name is getting modified with this name. So Alessa P. Hacker sees a problem. Circle all the appropriate criticism of this implementation. So my name is self dot name. So what is the self node name? So basically, what we are doing, every time we are just modifying this. I mean, we are not basically there is something called overwriting. We are not overwriting it. Basically, this name will be person dot name or the self dot name. I mean, this name will be here also. I mean, whenever you are modifying using the person dot name, then this name will get modified, right? I mean, you are not defining the attribute. Are you writing self dot name here? No, right? So you are not defining the object attribute. Okay, you can use it. If you use this, then the object attribute will be same as the class attribute. Okay, I mean, this self dot name will be same as this. That's what I mean to say. Okay, so basically this self dot name will be like this. Why? We will be just clarifying this little later on, that what is the class attribute, what is the instance attribute or the object attribute. See, we are not having the specifically object attribute. Are we writing self dot name equal something? Are we writing self dot name equal something somewhere? Anywhere are we writing? No. Which means we are not having name as object attribute. This name is just a class attribute, a global attribute, you can say. Okay, which if you want to refer, then you can refer using this person dot name or self dot name. I mean, if you want to access this, you can access this using person dot name or self dot name, doesn't matter. So maybe I can just show you using the code. For example, let's suppose, let's have the student class. Okay, so let's suppose, let me do here. Okay, suppose there is some name equal to uh, go classes. Okay, now suppose I don't write self dot name anywhere. Okay, I write self, which is okay. I write student dot name. uh, by the way, I mean, one thing you already know. Let me go step by step. One thing you already know. Let's suppose I only have this. Okay, suppose I print s1 dot name. What will get printed? Go classes. Suppose I print a student dot name. What will get printed? Again, go classes. So basically, this name you can print it using the class variable, class name, which is student, or using self. I mean, this s1 is nothing but the object reference, which is self, right? Or using the self dot name. I mean, outside you will be just using s1. Okay, inside you can use self. So basically, suppose there is a function which is def fun my, okay, print the name self. I have to anyway write, or anything you can write. I mean, doesn't matter, but by convention it is self. Okay, so what do you think it will be printing if I'm just having s1 equal to student, and then I'm writing s1 dot print the name or this function, whatever this function is. Now I'm using self dot name. Is this fine? Can I use self dot name? Yes, basically this name can be used using the self or using s1 or using student, or basically any other object name. Basically, since it is a global variable kind of thing, so you can use it using the class name, which is student. See, I've used it using the class name. I can use it using the object name also, which is s1 dot name. Or inside, if I want to use this, I can use this using the self or using any other xyz or anything. Okay, is this fine to everyone? That this name can be accessed using the class name, using the object, or using the self, right? Now, interestingly, if I'm only writing till this point, then it is okay. But the moment, okay, the moment I say something like this, self dot name equal to, so for example, currently, is this too confusing? Tell me. Suppose I'm writing something like this. Can you tell me what it will be printing? Can you tell me what it will be printing? My new name, if I'm giving Arab, will it print Arab? See, my new name I'm not even using, right? So self dot name is anyway this go classes, okay? So it will be go classes. But the moment, okay, the moment, let's suppose I write self dot name equal to my new name. Okay. Now I'm modifying this self dot name. Okay. Now I'm modifying this self dot name. Now if I print it, okay, after that if I print it, now this will not be referring to the original one. Now this is the moment, the first time I'm having the object attribute. This was the class level. This is the object level. Now the object at the object level, I basically you can say I've defined the name like my new name. Now it will print go classes because of this. But after that, I have defined my own object attribute, which is name. Now I'm referring my own object attribute. At this point in time, there is no object attribute, right? No object attribute at this point in time. But now I have the object attribute because on the left hand side I'm writing, which means now I just defined the object attribute, right? Just define the object attribute. So now if I print it, it will be object attribute. Now, interestingly, tell me if I do something like this now, what it will print? What this last line will print? See, now this is the object attribute, okay? See, let me just tell you. Suppose I do something like this. It will be printing. Since I'm not calling print the name function, it is h1 dot name is actually printing go classes only. Okay. Till this point, it is printing go classes. But the moment I have called this function, and in this function now I just defined my own attribute also. Okay. Now the self dot name or the s1 dot name will no longer be referring to this global variable. It has its own attribute, which is Arab now, okay, which is my new name. So now basically this last will print Arab. Okay, it is little confusing, I know, but little bit you might be getting. Okay, what I'm trying to say. See, the only thing I'm saying that this is like a global variable. Okay, this is okay till the point you don't have your own local variable. See, if you don't have this line, then self.name, s1.name, everything will be saying go classes. The moment you have your own local variable or own object attribute in any function, need not to be init function, in any function, then at that time the own object attribute will get printed and now will get I mean, it will be having its own attribute. Now after that, there is no global variable. For example, let me just make it very simple. See, let me make it extremely simple for you. Let's not have this function at all. See, can you tell me what will this print? It will be printing Go classes, right? Why? Because s1.name, student.name, both are Go classes. Now, suppose I say, so by the way, these both are Go classes. Is this fine to everyone? Now, I will be printing these two only, but before that, I'm writing just a small line. Okay. Let's suppose Aditi. Can you tell me what will the output of these two lines? Let's not worry about the other two lines. See, above two lines will say s1 dot name is anyway Go classes. Both are actually Go classes. The moment I say that my personal s1 dot name is Aditi, okay, my personal name now has got an Aditi. Now the moment I write s1 dot name, its own personal name is Aditi. Student dot name is still Go classes. Okay, student name dot name is still Go classes. See, s1 dot name is referring to Go classes only till the moment I don't have my own name. Getting my point? The moment I have my own name, it will no longer be referring to the global variable. Okay. For example, see, actually it was there, but it was quite late. So I thought I will be teaching it little late. But anyway, so basically the topic is class versus instance attribute. So here you have, let's suppose this attribute, right? Now I have two objects here. Can you tell me what it will be printing? C1 dot wheels and C2 dot wheels. What it will be printing? Both will be 4. Okay. If I have this 6, Then after that, both will be 6. Actually, C1 himself or C1 itself doesn't have its own variable wheels. Okay, so that's why it will be always referring to the global variable or the class instance, which is wheels. Okay, so anywhere in this code have I written C1 dot wheels equal to something or C2 dot wheels equal to something? Have I written this on the left hand side? Anywhere in this code? Tell me. On the left hand side, have I written this? No, right? So which means C1 doesn't has its own wheels till now. Okay. So this will be modifying this 4 to 6 and C1 dot wheels and C2 dot wheels will be same. Okay. Now let's just go to the next page. Suppose, so 4466 is answer. Suppose I have C1 dot wheels equal to 10 now. What will happen? Now there's a car. Okay. Inside this car, there's a wheels. It was earlier 4. Okay. So this wheels is 4. Now C1, C2 are the two objects which are basically C1 and C2, which are, you can say, two objects, right? Now here also wheels, here also wheels, right? Both are actually referring to the same variable until and unless they have this their own copy. Okay, so earlier we have seen that if I don't have this, then if I don't have this, then the moment you modify this 6, so both will be 6, 6 only. But the moment I have this 10, what will happen? Interestingly, since I have my own copy, so I will no longer be referring to this. Okay, the moment I have my own copy, I will be saying that, okay, now this is 10, right? This is 10. But C2 is still not having its own copy. So this is 10, but this has got modified to 6. So this is 6. Understood? C2 doesn't have still its own copy. So 10 and 6 will be the answer. Instance copy and the class copy. So basically C1 instance has its own copy, which means now it is no longer be referring to the car wheels. So let's have more example. For example, I have three references. So C1 has got its own copy of wheels. So now can you tell me what is the answer? Yes. So 866 will be the answer. Okay. There's a local copy or its own instance copy. This is the class copy. Okay. So that's the point here. So think of it like a recipe. Recipe is like a class. All cakes have 4 layers, and every cake baked follow this rule. So basically, uh, but if one baker decides this cake has 6 layers, so suppose you are changing just for one cake, okay, then it is just for only one cake or just for that particular object or instance. Understood? So let's solve one question probably. Can you solve these two questions immediately? So you have C1, C2. What is the output? C1 dot wheels will be what? Here, I think 4 will get printed. Here, again 4. Now you have 6. So both will be 6, 6, right? What about this? See, 4, 4. Then should it be 6, 6 because I modified card dot wheels? No, right? They have got their own copy. So now it is 10, 20. Understood? 4, 4, 10, 20. So basically here B is the answer. Here 4, 4, 6, 6, A is the answer. So A is the answer and B is the answer. Okay. Understood? So basically the moment I write this on the left hand side, then only I'm having my own copy. Otherwise, I'm just always referring to the local global variable, which is shared by all. Okay. This is one concept which is called class instance class variable versus the class attribute versus the instance attribute. Okay. Class variable versus the instance variable or the class attribute versus the instance attribute. Okay. So this was a little digression. I think I don't think we should be jumping to that for now. So for now, just to solve this question, I wanted to tell that particular thing. Actually, I haven't noticed that this question required that concept. So maybe I put it here, but I should have put it later on. But anyway, see now here. See, it might be looking a little complicated. So let's just skip this question. It is not needed. Okay. The only thing that I wanted to convey that if you don't have self dot name on the left hand side till that moment your attribute is not defined. Okay, that particular instance doesn't has its own attribute till the moment you have self dot name or self dot something on the left hand side. Okay, The moment you don't have this on left hand side, your object doesn't have its own attribute. Okay. So the answer is A. You can do it later on. Okay, answer is A. But I hope the concept is clear to everyone that object attribute is defined only at the moment you have s1 dot name on the left hand side. You can do it in any function. You can do it if you're doing it in any function, you have to write self dot name. If you're doing it outside the function or basically maybe outside the class, then you have to write, or you can do it on the fly also, as I told you, right? On the fly also you can do it like this. Now there is very interesting concept which is like everything is an object in Python. Everything is an object. So what does this mean? Let's just see. Okay. So by the way, I'm not saying this. I mean, everyone is saying this who is using the Python, or basically Python developers have figured out that everything is an object in Python. The way Python got developed is basically that they made sure that everything is an object. So what does this mean? Suppose you write this x equal to 42. Now you write print type of x. So suppose if I do it x equal to 42, then write print. What do you think it will be printing? What is the type of this x? It will be printing class int. Interestingly, it is saying class. Okay. So basically, this x is also the object actually. The moment it say class, it means object. Okay. X is also the object of the class int. Okay. It means the way to read it is like this, that the x is an object of the class int. So basically in Python, even the integers are also the object. And where is this class defined? Internally, it is defined. The moment you write x equal to 42, actually the Python creates the object of class int. Okay. So basically it is an object of class int. This is not a random integer. It is, I mean, it is not an absolute integer. It is an object actually. This x is an object, not a directly an integer. Okay. So this x, I mean, you don't need to worry about it because Python has already made sure that even if you do x plus 2 or something, it will work. Okay, because they have defined this plus operator. There is something called overriding the operator. So we don't need to know this much for our purpose. But yes, we just need to know that that everything is an object in Python. Okay, so this x is an object. Okay. This pi equal to 3.414, if you write it, this is also, if you print the type, this is also an object of class float. If you write something like this is object of class complex. If you write flag equal to true, if you print the type of flag, it is also an object of class boolean. Okay, everything is an object. If you write s equal to string, this is also the instance of the object of class string str. This list is also okay, lst. This variable is not just a random variable, it is the object of class list. Okay, these all are the objects. Anything you see is an object. Even the none. Okay, none that you have. Okay, this, if you print the type of the none, okay, type of this nothing, this is also the class none type. There was some class defined as none type. Okay, you don't need to know much about it, but yes, there is some class defined none type, and this is also an object of class none type. Even the functions that you have, okay, def greet. Okay, even this greet, if you type the type, if you want to print the type of this function, then it is also object. So everything is an object. Okay, this is also object of class function. Understood? So everything is an object. Even, okay, even if you have let's suppose class, okay, class car. Okay, and then you write the class car, something like this, then you print the type of this car, then this car is also an object. Okay, everything is an object actually in Python. Anyway, we don't need to be worrying much about it, but just know that everything is an object in Python. Okay, and that is why you might have noticed that, let's suppose you are defining any list. Okay, then you can even write the function name here, you can write 5 here, you can write anything. Okay, because everything is an object, so it is easy for the Python to work. They made it, very nice. Now suppose I have something like this, l equal to 1 2 3. Is this object? Type of this l, What do you think? Is this object? Yes, right? Just a second. So it is an object of class int. Now, if it is object, then can I define an attribute on the fly? Let's suppose age or any other attribute. Can I define any attribute on the fly? What do you think? Equal to, let's suppose, 50. See, there is a problem here. Earlier we have seen that if you have any object, then you can define any attribute on the fly. Okay. But if it is user defined class, okay, if you are defining your own class, then it is true. But if it is inbuilt class, for the inbuilt classes, it is not true. Okay, inbuilt classes has the protection. Basically, those classes, those attributes are written in C language. I mean, and it doesn't provide that flexibility. So anyway, like inbuilt classes doesn't have this flexibility. Okay, and it is good also. Otherwise, it will be too much mess. For the inbuilt class, you can't define the attribute name on the fly. Otherwise, if you have your own class, then you can write attribute name on the fly. Okay. If you have your own class, so for example, if you are my own class, then it is fine. I mean, if you are having your own class, then it is okay. Okay. I mean, you can print the age, which is 50, if you are having your own class. But if it is inbuilt class, then you cannot do it. Okay. Just a small thing that I wanted to convey. But everything is an object in Python. For example, if you write type of x, it will be class int. And since it is an object, it might be having some functions associated with it. For example, dot bit length is one of the function with this integer. Okay, so you can see that, okay, how many, bits of this 42 is. Okay. So dot bit length, dot 2 bytes, there are many other functions. Okay. Python 42 is not just a raw bits, but an object of class int. Or in other words, basically x. Okay. X is not a raw bits. Uh, X is object of class int. Okay. So what does this print? If you have this type of this flag is bool, right? Okay. So every answer points to the same truth, which is everything is an object. Is everything in Python is an object. Okay. I've taken this from the MIT slides. So this is the link. So everything in Python is an object. Okay. So I hope this concept is clear that everything is in Python is an object, right? Now, we have already seen this, that was the class versus instance attribute. Maybe I think I can go over this once again. So basically the class attribute is one thing, which is you're defining as a global variable. Object attribute you can define anywhere in the sense using a self inside any function or even outside on the fly. Okay. So basically object attribute we can define almost anywhere. For example, uh, inside any function using self dot, let's suppose, name equal to or something, right? So basically this has to be on left hand side. This has to be on left hand, right? Or if you want to define on the fly, then you can also do it. On the fly means not in class, but after the object creation. Okay. So these questions we have done it. Yes, this is also done. Okay. So that's all I wanted to discuss today. So I hope now you have got what is a class, what is object, what is class attribute, what is object attribute, right? So self, what is self, how it is working, and we have seen many examples. So I hope everything is now clear. Understood? Have you understood everything, or there is any confusion regarding these are small concept? What is self? Regarding these, any confusion? Should we always be using the word self, or we can use anything? We can use any other variable name, right? So self is just a convention. Okay, great. Now, if you want, you can have one two more questions which are optional questions, I can say. Okay, so these list questions are little optional questions, not very tough, but if you want, you can just check this question. So what this question is saying? This question is saying that there's a wheels which is a list. Okay, now C1 and C2, you are defining C1 and C2 objects. Now C1 dot wheels dot append 1, C2 dot wheels dot append 2. Now if you're printing C1 dot wheels, what it will be printing? What it will be printing? Tell me. See, this is the global variable that you are referring, right? Have you defined your own C1 dot wheels? At this point in time, are you writing C1 dot wheels equal something? No, right? So C1 dot wheels dot append one. So basically you're appending, basically you're writing one here. And inside this only, you're modifying this only, right? You're writing two, isn't it? Are you having your own copy? That's the only question that you have to ask. Okay, that's very simple. Are you having your own copy? Since you're not having your own copy, so that is why C1 dot wheels is actually nothing but car dot wheels. It is same as, okay, car dot wheels, same as C2 dot wheels. Okay, so that is why C is the answer. So answer I have not written, but yeah, C is the answer. Anyway, it was optional question, but only thing I wanted to say that we have not written C1 dot wheels anywhere on the LHS, right? We have not written C1 dot wheels anywhere on LHS, right? So C1 doesn't have doesn't has its own copy of wheels. You are just modifying the global variable, you can say, right? I mean, you are just modifying this. Append means it will be just appending one, two, or whatever you like, right? Is this clear to everyone? Now, again, this is also optional question. One, two questions that I have, you can quickly solve it. Now, again, this is optional question. Tell me what is the answer. Is C1 having its own wheel? C1 having its own wheel? Tell me. Yes. Where you have written it? In this line, isn't it? In this line, self dot wheels, it is making sure that this is make this line is making sure that C1 has its own wheel, C2 has its own wheel. So so both are having their own wheels. So this C1 dot wheels and C2 dot wheels are not related to each other in any way. You are appending one here, you are appending two here, so that is why A is the answer, right? So you can say every object has its own wheel because self dot wheels you are adding, right? Okay. Is this understood, everyone? So C1 dot wheel and C2 dot wheels are not related to anywhere to each other. So basically, A is the correct answer. What about this? So A, I'm calling A, right? So basically, both are referring to the same global variable. This A dot foo dot append 5. Okay. So I'm appending 5 here. I do not have A, it doesn't have its own copy, B doesn't have its own copy. Again, by the way, it's optional, right? And if I just print using the B, then what it will print? It will print 5, right? It will print 5. So answer is 2. Okay. Why? Because using A, I can append, but using B, I can access. See, both are the same thing. That's what I'm saying. You don't have A and B doesn't have their own copy. That's why I'm trying to say again and again. Until and unless you write A dot foo equal to something, you don't have its own copy. Okay. So that's all. These were few optional questions we wanted to solve. So thank you, everyone. I hope you understood classes, objects in Python, right? Is there any doubt? Is this clear or there is any confusion, by the way? Okay, this is clear, right? Thank you. So now we will be basically doing linked list using the Python. So linked list is in the syllabus. So before the linked list, we should be knowing, okay, what are the classes, what are the objects, because linked list will be having the classes and objects. Okay, we will be implementing linked list using the classes and objects. Okay, thank you, everyone.